When King Hieron in 3rd BCE was not able to solve the problem of delivering heavy objects to different parts of the world through the sea route, he assigned this task to his trusted engineer, mathematician, and architect. This man is well known to all of us. He was Archimedes. Well, it's quite obvious that heavier objects sink and lighter objects float, unless buoyancy comes to our picture. Ships, cruises, submarines all work on Archimedes' principle. This principle is quite descriptive about how objects behave with fluids. So what does the principle say? When an object is fully or partially immersed in a fluid, the upward force is equal to the weight of the displaced fluid. To know buoyancy, you should be clear with the concept of density. Density is quite an icebergy topic about matter. It tells us how matter is compact or dense. The size doesn't matter in density. Even if a large wooden log floats and a pebble sinks, it's just the science of density that matters more to us. Now coming to our main topic about buoyancy and how Archimedes' principle was useful for King Hieron. The upward force which acts on an object is called the buoyant force. In order to make a heavy object float, you have to displace the amount of water which is equal to the weight of the object. So when you build a floating vessel, do remember the weight of the body should be less than the buoyant force or equal if in case it's an underwater submarine. Now here comes an interesting question. Why do fluids exert an upward buoyant force? Why not down? Because if you see, the acceleration of the object is downward due to the gravity, which is already acting on the object, and the buoyant force is opposing it. So in order to get a downward buoyant force, the pressure on the liquid at the top must be greater enough to sink a submarine or any immersed object, which is seemingly impossible. As we dive deep inside fluids, there is more and more pressure. We can prove it by this simple experiment. Take a bottle of water and make 3 holes at the top, middle and down. And you can clearly observe the water released from the bottom flows with greater pressure. So we can say that the pressure at the bottom is greater and so the water pushes an immersed object leading to buoyancy. It might not surprise you while taking a bath, you might do the eureka. Have a great shower next time.